Is a polynomial, not a polynomial, not a polynomial. That is it. That is the end of the video. Thank you for watching. Don't forget to like and subscribe. And I am, of course, just kidding. Because in this video, we're going to get into exactly what a polynomial function is and how to identify one just by looking at the equation. And we'll start by looking at this particular example right here so that we can understand the definition of a polynomial function when it comes to looking at an equation. The equation of a polynomial function will always contain a sum or difference, right? Adding or subtracting, a series of terms that have a whole positive power on x, okay? A whole positive power on x. So important that I had to write it, okay? The power must be whole, meaning it can't be a fractional value or a decimal value. And the power must also be positive, okay? No negative numbers. Notice that I didn't say anything about zero. So when we look at this particular function, we ask ourselves, are each of these exponents whole and are they positive? Okay, well, 3 is a whole number and it's a positive number. 2 is also a whole number and it is also a positive number. Now remember, this term right here has an imaginary 1 hanging out there, and 1 is a whole positive power. The last term is a little confusing because there doesn't seem to be a power there, but remember that any constant can be written with an x to the power of 0. X to the power of 0 is just 1. So 1 times x to the power of 0 is 1. Now we're going to consider 0 to be a whole number. It's not necessarily a positive number, but it's not a negative number. So we're going to accept this as fitting into the definition of what is considered a polynomial equation. So I'm going to move these two criteria down here, and I'm going to say that this is in fact a polynomial function. Moving along to the second example here. At first glance, you're going to look at this thing and you're going to say, okay, well, I definitely have a power, but the power happens to be a variable. We don't actually have a power on x at all. We have a power on 2. So this does not qualify at all. So this term right here really makes this whole function not a polynomial. But if we look at the second term, we're adding an x squared. This 2 here is a whole positive power on x, but because of this term, we have to unfortunately disqualify this and say that this is not a polynomial function. Now this last example is my favorite, and that's because when we look at it at first glance, okay, we appear to have whole positive powers on x, okay? X to the power of 1, whole positive power. That 1 there we can write as x to the power of 0, and the x squared in the denominator appears to be whole positive, right? So we should be able to say that this is a polynomial function. But if you did that, you'd be incorrect. And here's why. Now you have to remember that when you have a rational expression like this with a variable in the denominator, we can actually rewrite this in a different way. And I'm going to do that for you here so you can understand why this is not polynomial. I'm going to keep my numerator of x plus 1 here, and I'm going to place that inside some brackets because there's an exponent rule that tells me I can take a denominator and I can bring it up and multiply it by the numerator. But when I do that, I have to make the power negative. Okay, so what I actually have here is a product of an expression that has whole positive powers on x with another expression that actually has a negative power on x because I'm multiplying 2 times negative 1, also known as negative 2. Okay, so don't get fooled by that one. This is in fact not a polynomial function because it breaks our whole positive power on x rule. All right, so now that you understand what the equation of a polynomial function looks like, it's time to start doing stuff with polynomial equations. And to get started with that, you're going to head over to this video right here, and I will see you there.